What are we going to cover today?
Could we maybe go to the same spot that we were yesterday, but go to a different section?
Yeah, I actually, let's see, I have that saved. That URL address. Sorry, my computer's running a little slow.
Oh, you're all good.
Oh, it's running a lot slow. There it is. And that's it right there. Ooh, copy here. Why does it say copy there? That's kind of weird. All right. This time, let me save it as a favorite. Oh no, I want to. We're always going to Algebra 1. Are we always going to Unit 1?
Could we go into Unit 2?
Okay, so this is really what I want to save is this page here. Okay. All right. Probably down where?
Um, could we do the graphing homework, I think?
Yeah, you're gonna have
Or
to give
the
me
what function and notation?
the very top one opposite 927.
Yeah.
Okay. Or you want me to do the one on the right, not the one on the left, right?
Yeah, the one on the right.
Not the notes, but the homework or the problem.
Yes.
Okay. Make sure I got this recorded. I do. Okay. Blow it up a little bit. All right. So, what would the graph of the parent function look like? That's really the first thing to do.
Um, I don't really know. I forgot, but isn't it the y-axis or something?
Well, it's actually in the form of y equal mx plus b. It's just that b is 0 and m is 1. So you get y equal x. That's what that is. Remember
All
that
right.
y and f of x mean the same thing. It's just f of x is a little bit more robust notation. You can say a few more things with f of x. Like you can say f of x minus 4. I can't do that with y. So that's why this would be called f of x. Okay? So if it's the same as mx plus b and b is 0, so its y-intercept is right there. What is the slope?
4? -4?
No, I'm talking about that one right there. What's the slope of the parent function?
Would it just be 1 since it's
Yes. So you have an angle that's 45 degrees. That's that line. That is y equal x. Okay?
okay?
Now, there are 6 types of transformations. There are 3 horizontal ones and there are 3 vertical ones. It's hard to remember 6 of anything, but if you break it up into 2 types, 3 horizontal and 3 vertical, it's a lot easier. Of the horizontal transformations have the changes taking place inside the parentheses. For instance, if I said something like f of minus x, that's a horizontal transformation. If I said f of 2x, that is a horizontal transformation. Or if I said f of x minus 4, that's a horizontal transformation. Vertical transformations would look like this. F of x plus 4 outside the function, or 2 times f of x outside the function, or negative f of x outside the function. So those are your 3 vertical transformations, and those are your 3 horizontal transformations.
Okay.
That's the way to memorize it, because it's pretty easy to memorize something, just 3 of something.
Yeah.
Okay. Now, let's erase all the vertical. So, because we know what we're looking at, that x minus 4 is like inside the function. So we know it's horizontal. Now, there's 3 horizontal things you can do. You can shift it left or right. You can shrink it or stretch it left or right, or you can reflect it. This is a reflection. That is a linear shift, and that is a linear or horizontal shrink. So we're dealing with the linear shift. And whenever you're dealing with math, it's always x minus h is your standard. So in this case, we're looking at x minus 4, which means the shift is 4 units. It's a positive 4 units. Positive is to the right. So I'm going to shift this thing 4 units to the right. 1, 2, 3, 4. It's got to go through that. It's got the same exact slope. So that's how you do it.
Okay.
Now, let's go to the second one. This has got a combination of things, but I'm still going to start out by drawing the parent function. Both of these problems have this same parent function. Notice that the adjustments to this function, or the transformations, are both outside the function. In fact, there's 3 of them. What's the negative sign do?
Doesn't it move it downward?
No, it's a vertical transformation. All 3 of these, we've got a negative sign, we've got a 2, and we've got a plus 3. All 3 of those are outside the function, meaning they're all vertical transformations. Okay? Well, when you see a negative sign, that means a vertical reflection. So the first thing I'm going to do is vertically reflect it. You always do your reflections first. So this thing right here would just be minus f of x. You with me?
Yes.
Now let's take the number 2. Is that vertical or horizontal?
Isn't it vertical?
It's outside the function, so it's vertical. And it means twice the function. So if this was the old function value, the new function value is going to be twice as far away from the x-axis. In other words, if I'm down here, the new one's going to be down there. So if I was graphing strictly that is minus 2 f of x. And we call that, too, a vertical stretch factor. Now, when you're looking at straight lines, it's hard to see that that is a stretch. If we were looking at curved lines, it would be a little bit more easy to see that that's a stretch. But just take my word for it. And the reason I know is that the original function, that would have been the value, right?
Yeah.
Well, we're multiplying it by 2. That puts it down there. In the original function, that would have been the value. We're multiplying it by 2, so it puts it down there. Okay? So the green line is minus 2 times f of x. And then we have one more transformation. Is that vertical or horizontal?
Vertical.
Correct. All three of them are vertical. This is a shift. This is a lot like this was a horizontal shift, 4 units to the right. This is a vertical shift, meaning 3 units up.
Okay.
Because all I'm going to do is take my last green line, and I'm going to move it. I'm going to take 1 point on it, move it 3 units up, and then draw a line that's parallel to my other green line. And that purple line is the final answer.
Okay.
The best way to do these transformations is always one at a time. In other words, this method, this had only one transformation in it. This had 3. So I had to draw 4 different lines to get my final line. And one thing to know about transformations is always do your reflections first. It will matter. If you do a vertical shift first and then the reflection last, you end up with a different graph.
Okay.
All right. Here, let me scroll up a little bit. I hear a kitty cat in the background.
Yeah.
Or your end.
Yeah, he's probably hungry.
Okay, so number 3, just explain the transformation. Starting from left to right, what's the negative sign do?
Reflect it.
Over what? There's 2 types of reflections. There's reflections over the x-axis, and there's reflections over the y-axis.
Wouldn't it be the x-axis?
Since it's vertical, yeah. If you think about reflecting over the x-axis, that is a vertical reflection, right?
Yeah.
If you reflect over the y-axis, that's going to be a horizontal reflection. So it fits with the other 2 types of things. Okay, what's the 3 do? Vertical or horizontal?
It's vertical.
And now is all you have to decide is whether it's a stretch or a shift.
Isn't it a stretch because it's in front?
Stretch because it's multiplying the function. It's a shift is where you just add it. Stretch. How do you spell stretch? Stretch? I don't know how to spell stretch. And finally, what is that plus 4? First of all, is it vertical or horizontal?
Horizontal.
Because it's inside the parentheses, correct? Is it a stretch or is it a shift?
Isn't it a stretch?
No. Whenever you're adding stuff or subtracting stuff, you're shifting. When you're multiplying stuff, like that 3 was a multiplier of the function. That's a stretch or a shrink, but it's not a shift. You have three kinds of things. You have stretches, shrinks, and shifts. Stretches and shrinks are when you're multiplying. Shifts are when you're adding or subtraction. So we know it's a horizontal shift, but we have to say which way. Is it left or right?
Right, because it's positive.
What's the standard? The standard is x minus h. So what is h here?
The 4.
H would be -4. If I had an x minus h and h was -4, it would come out to be x plus 4. So when you see x plus 4, h is actually a -4, which means left. 4 units. Another way to think about it is if that's a negative sign, you're going right. If that's a positive sign, you're going left.
Okay.
I just find it easier. Most math, positive is to the right, negative is to the left. So it's kind of backwards from that if you do it that way. But if you always remember that all your math equations that you memorize between now and when you're done with high school are going to be x minus h, all of them. So remember that. So when you're looking at an x minus 2, h is positive 2, which means to the right.
Okay.
Okay? So that's all we have. We have the reflection over x, which is vertical. We have a vertical stretch. And we have a horizontal shift to the left by 4 units. And actually this vertical stretch by factor of 3. In other words, it's by whatever that number says.
Okay.
4, write a linear function with a horizontal shift of 3. So here's our parent function. What would a horizontal shift of 3 be?
Would it be a +3 in front of the F?
No, horizontal, everything is inside the parentheses.
Oh. So then it would be x +3?
Well, it doesn't say which direction, so it's a little ambiguous. It didn't say left or right, so we'll assume it's to the right. To the right would be x minus 3. To the left would be x plus 3. Vertical shift of -2. How do I do that?
Wouldn't that one be in the back?
Yes, added on to the function, definitely outside the function, and added or subtracted. Shifts are always added and subtracted. Just like this -3 is a shift, so it's being subtracted. The vertical shift is being subtracted from the entire function. And finally, a shrink of 1/2, and again, they don't say whether they mean vertical or horizontal. That's really a bad mistake, incidentally, because there's absolutely no clue as to whether, unless this word vertical applies to the next two things, and if that's the case, a shrink, you're going to multiply the function by 1/2 if it's a vertical shrink.
Mm-hmm.
Stretches are where it's greater than 1. Shrinks are where it's between 0 and 1. So since this is a shrink of 1/2, we multiply the function by 1/2. And that's our answer. Now, it says write a linear function. So if I wanted to write if f of x was equal to x, like in the previous cases, then my function would be 1/2 x minus 3 all minus 2. So this would answer the question. This also would, I suppose, more generally, using the f of x notation. But this would be a specific function that satisfied all of those things.
Okay.
let's see, we got about 5 minutes. Let me scroll down this page. Okay. Could probably do both of these. So what would f of 10 be?
Wouldn't it be a horizontal?
No, that's a little different. Mainly we want to get you used to this notation. F of t means one thing. It's the number of people in millions. So if f of t is 1, it's 1 million people. If f of t is 3, it's 3 million people who own cell phones t years after 1990. So the number of people that own cell phones is going to be a function of t, and t is the number of years after 1990. So f of 10 would be what? What does f of 10 mean?
10 million?
Means in the year 2000, right? 10 years after 1990. So in the year 2000, how many people own cell phones?
100.3.
100.3 million. It's in millions. So it's true, it's 100.3, but that means 103 million. Or 100.3 million. What does f of 0 mean?
In 0 years?
Which is which year?
1990.
Okay, so what does it mean in 1990? How many people own cell phones?
20.
20 million. What's that mean?
In in 20 years, there will be a greater difference than in 15 years.
Yeah, it means the number of people that own cell phones in 2010 is greater than the number of people that own cell phones in 2005. Okay? All of which makes sense, right? This fits with reality. In 1990, there probably were only 20 million people that had cell phones. And in 2000, there were probably 100 million. That's about a third of the country. Now, this last statement here, what does that mean?
Then at 25 years, it's equal to 26 years.
Yeah, so 2015 and 2016, there was no growth. The number of people that owned cell phones was the same in each of those years. They don't tell us what the number was. They're just trying to get you to understand what that notation means. Okay, real quickly, let's do the last one. When you see an f of f function, and then you see something in the parentheses, is all you do is whatever's in the parentheses, substitute for x. So what is f of 0?
-2 times 0 plus 1.
Which is?
1.
Good. What is f of 3?
So -2 times -3 plus 1.
What's that equal?
7.
Good. And now f of x, well, they've told us f of x is this, equals 11, they're saying. So solve that equation for x.
Wouldn't it be -5?
You got it. Ellie, sounds like you're doing okay. Think you understood everything we talked about today.
Yeah, that made a lot more sense. I got super confused with like the horizontal and vertical shifts.
Well, that's why you want to break it. You want to know that there are 6 transformations, and there are precisely 3 horizontal and 3 vertical. And when you think of it like that, it's easier to memorize. Because,
yeah,
you know, one of the 3 are reflections. So the only other things you have are shifts and stretches.
okay.
All right? All right. You have a good day, and I'll talk to you at our next session.
Thank you.
Welcome. Bye-bye.